Earth science time. Groundwater. I don't like the title of this. Let's call it something different. Let's call it caves. Well, we could just call it groundwater caves.
No,
that's
I
fine.
just erased everything, so.
Well, call it either groundwater weathering and erosion, like your book calls it, or call it groundwater caves, or call it caves. All of those are fine titles. Okay, so the first thing we talk about, and we've talked about this once before, I think even on a video, but let's just review this idea. We're going to talk about carbonic acid. If someone is in chemistry in here, they should be able to provide me the formula for carbonic acid. If it was, if it ends in ic, right? What was the polyatomic ion it came from?
Ite.
No, try again.
At. Ois. Not at.
No. Eight. Thank you,
Carbonate,
Skylar.
which is CO3.
Carbonate, right? Carbonate, which is
CO3.
CO3.
Is it -2?
Yeah, it's -2. So if it's an acid, though, what must it have in front of it if it's an acid?
H.
Yeah, so,
Or hydrogen.
and how many H's because it needs to match the charge of the carbonate?
2.
2. So carbonic acid is H2CO3. Thank you, Thailand's brother. So carbonic acid, and what's special about carbonic acid is that it's formed in this chemical reaction. CO2, you know what this is. Do you know what this is? Carbon dioxide plus H2O. You know what that is? Water yields H2CO3. You can see even if we just add them up, right? In the same way that 1 + 1 = 2, C, there's a C over here, O2 plus O is O3, and then there's the H2. So carbon dioxide from the air, which you're aware is just like all around us, right? The plants use that to do their photosynthesis, plus water, which is kind of the point of these last two chapters, yields this carbonic acid. So basically, just by falling through the air, which contains carbon dioxide, water can become more acidic, and when it becomes more acidic, it can then do what? The reason we talked about this last time is that it can then do chemical weathering, specifically to what rock, usually? You remember? Limestone. Because limestone is made out of what mineral? Calcite, which has the formula? You remember? What's the formula for calcite? Yeah? CaCO3. So this can combine with carbonic acid to release carbon dioxide, and it basically can dissolve the limestone over time, right? Limestone is more resilient than like if you put a sugar cube in water, but over time, this and this can react, which will allow the limestone to dissolve. So what happens here, why this is important, again, we talked about this initially because we were talking about chemical weathering of sedimentary rocks. And that's still what this is, except now we're going to talk about how, if you have this chunk of limestone, do you remember what the symbol we use for limestone is? No, I'm about to remind you though. We've got these lines, you should draw this. And then it kind of looks like bricks. It's like vertical lines offset every other horizontal line. So we have this chunk of limestone here. Nice. Where might we find some limestone? What ancient environment is limestone evidence of, if you remember from the Sahara video?
The pyramids?
They used it in the pyramids, but what did they find in the limestone of the pyramids, do you remember?
Those
Little seashells, because this limestone is almost always formed in what kind of environment that we haven't talked about yet? Oceanic, a marine environment. So anyway, that's beside the point, but this limestone probably formed in a marine environment, and limestone will develop these cracks. In fact, the reason that this is the symbol for limestone is because it gets these cracks kind of along these lines. So say it's got a crack here, and this can happen for a lot of reasons. Maybe plate tectonic activity thousands of miles away, maybe some other kind of fault nearby, maybe a root goes into it. All kinds of reasons the limestone can crack. But for whatever reason, it develops this crack, right? And now that it has a crack, there's a little depression in the surface. Sometimes you feel like that too. Sometimes there's a depression in your surface. And when the rain falls on it, which by the way, the rain has combined with carbon dioxide in the air to make this carbonic acid, which makes it even better at dissolving this. Where's the rain going to go? And into a little crack, and eventually it's going to seep in through here, right? And as it does that, it's going to dissolve the limestone away, which will make the crack bigger. The crack's going to get bigger and bigger and bigger. And where can only two things can happen here, because limestone is impermeable when it's not cracked. So two things can happen to this water.
They can take it right or they can go shoot.
Well, okay, so it can either do what? What might happen? What are the two things that could happen to this water? Can it run off?
No.
Not really, because it's
They can
flat.
Go infiltrate.
It can either infiltrate further by continually eroding, or what's the other thing it could do? Evaporate. So over time, when enough water accumulates, it just dissolves more and more and more of this. And you see, because the crack is pretty narrow and vertical, it accumulates on the horizontal surface underneath, right? And so it gets this, it still keeps coming in through this relatively thin crack, but the hole gets bigger and bigger and bigger and bigger. And sometimes it branches off and gets bigger down here. And this is starting to look like something, hopefully my drawing is blue spaghetti. But what is this representing, probably?
Okay.
A cave. This is how caves form. Cave. Or sometimes a cavern. We call it a cavern. In fact, we should call this a cavern. A cave is a slightly different thing, but this underground in a limestone place is called a cavern. A natural underground opening with a connection to Earth's surface is called a cave or a cavern. Some caves form three-dimensional mazes of passages, shafts, and chambers that stretch for many kilometers. Looks good to me. Have you ever been to one of these? You've never been to a cave?
Yes.
I've been
I
to
have.
a cave national.
Yeah, okay, there, that's
Our
what,
class took a trip to.
yeah, to Wind Cave probably, right?
Yep.
Which is the, if not the largest, I think it's either the largest in North America or it is the most unexplored area of any cave in North America. But it formed exactly in this way.
Really?
And both of those could be wrong, but I think it's relatively large. Anyway, it formed in this way, right? So what kind of rock would we expect to find in fact, if you go on the tour again sometime, yeah, it's limestone. The lady's going to talk about two minerals, calcite and aragonite, which has the exact same chemical formula, just a different crystal structure. But that cave, almost every underground cave in the world, in fact, every one that I'm aware of, is made of limestone. There are such things as sea caves, which can be made of pretty much any kind of rock, because the same thing happens except horizontally when the waves crash into the rock over and over again. But underground caves that form on relatively flat plains on the surface of Earth are almost always in limestone, or I would even say always in limestone. So let's imagine we're inside this little cave here. Here's us inside the cave, because you can get down in a cave, right? Gets all hollowed out, fills up with water, maybe there's some water, but in this case, where would my water be? Just exactly how I've drawn it, where would the water exist? Yeah, in the bottom one, because just like water does on the surface, it's going to flow downhill. And so these might be full of water, but we might have a relatively dry place to just like, here's me. Who else wants to be in the cave with me? Levi, you're kind of shorter than me, but not by much, so there we go. Me and Levi hanging out in a cave. Who else? My dog.
What about your son?
Well, he's too young to go in a cave. Sadie's 10. She'll be fine. Anyway, so we're in the cave, and what kind of things, even if you just know from a movie, what kind of things, or from your vocab, what kind of things are we going to see in this cave probably? Like what features?
What are those things called?
What did you say, man?
Moss.
Matt. Sorry, what?
Moss.
Okay, yeah, so there might be wildlife down here. In fact, this is a really good place for animals to make a home because
They're
it's
like
protected.
Stalagmites.
Okay, so we might see some stalag. Do you know which one's which and how you can remember? I know which one's which, but I'm the teacher.
The STAL one is like on the ceiling and the stalagmite is on the ground.
They both start with STAL, but the stalagmite
Is on the ground.
is on the ground.
I can-
Let's draw that. Stalagmite is on the ground. You know how you can remember that? Stalagmite might reach the ceiling. I hate these things, but it might help you remember. It might reach the ceiling, right? Because it continually grows taller. We're going to talk about why in a second. Well, first, why do you think this thing is continually growing taller? What's forming this?
Water.
It's dripping.
Yeah, the water drips down, like it comes down from the rain. Some of it, just like if you, kind of wish I still had my coffee cup so I could show you, but if you pour a little bit of water out of your cup, a lot of times a drip will come down the side, right? So even though most of the water is coming straight down here, some of it's going to drip, and where it drips, it carries sediment, right? It carries dissolved limestone from all the way up here. Its whole path, it's dissolving limestone, and then when it drips, some of that limestone is deposited, right? And over time, stalagmites they're not pointy like this. They look ugly like little piles of turds because they're kind of formed in the same way. They're like a drip, and there'll be a little like flat
It looks
cow pie
like
shape,
that.
and then another one on top of that,
It looks
another
like
one on top of
what
that.
The ice cream machine looks like when I
Okay.
clean it. It's like
Good.
one little layer.
Yeah, well, they probably form the same way. So stalagmites have these kind of lumpy looking, relatively turd shape. And then, but also here on the ceiling is also forming another prettier thing. What is it?
I can't say that.
Oh, well, someone else say it then.
Stal-
Well, if I pronounce this stalagmite, how do we think we say it? Stalactite. Stalactite. Can you guess why we might call it? How do we remember that the stalactite is on the ceiling? It's got to hang on tight or it's going to fall down. I hate myself when I say that. But that is, it's a relatively good way to remember them, right? Stalactite is on the ceiling. Stalagmite is on the ground. Meanwhile, over here, right, there's probably a lot of these on the cave ceiling. There's probably a lot of stalagmites separating me from my dog. But what happens if eventually? What's the end process here? What's going to happen if
Fall down.
maybe?
They're gonna fall.
No,
Sometimes.
they meet.
Okay, one of those two things. If the stalactite doesn't fall down and the stalagmite doesn't crumble, then they will meet. And when they meet, it's going to form... Oh, it's going through my dog. Sorry, Sadie. It's going to form a lumpy on the bottom, pretty on the top column. I think your book refers to this as a dripstone column.
Build. Yeah.
All these three things together, stalactite, stalagmite, and this thing, the column, all together are called dripstone. Can you guess why they're called dripstone?
Because they drip.
Yeah, because they're formed by dripping water. But the column, sorry Sadie, the column is when they meet. This is looking like an actual cave scene. Good job.
Where'd Sadie go? Did she run away?
She,
She got impaled.
yeah, stalagmite grew into her. But, okay, you should also be aware that, in general, like, these things are going to take at least decades and probably centuries to form. Now, pretend there's another one up here, and maybe this is where it first started, actually. We can pretend this is where the cave first started to form. And as the water runs on the ceiling of it, the ceiling gets thinner and thinner and thinner, okay? I'm going to erase the word cavern, because then Tylee, in her truck... What color is your truck, Tylee?
What?
Like maroonish?
No.
Yeah, it is.
Right.
Brown. Perfect. Okay. Oh, I'm sorry. It's lifted.
No, it's not.
I gotta draw the smokestacks on it too.
Yeah.
Oh, wow.
She,
No,
she,
today.
yeah, she. What do you call it? She?
Whoa,
there's-
Tylee, that's a monster truck.
Named Gino, but
Whoa, why are you hanging out the window?
Tylee's blowing
Okay,
the floor and then
yeah.
she's going
It's
down.
supposed to be going the other way.
It doesn't matter where she's going. Anyway, so what's going to happen? I mean, you can see as this thing gets thinner and thinner, which is probably not while she's actually perched on top of it. But if she goes over a spot where the ceiling is already thin because of years of erosion,
Sink.
sinkhole.
She's gonna
Sinkhole.
join us in the cave.
She's going to join us. That's a very pleasant way to say she's going to fall to her death in a sinkhole. But yeah, sinkhole. So right down. This is how a sinkhole forms. Right when the cave ceiling wears away enough, something, usually just gravity, but maybe a heavy object comes across it, a sinkhole can form. Right. And this is pretty dangerous in places like for some reason I think about this happening in Central America. Maybe there was like a news story about it happening once there when I was a child and I just remembered it. But
Are there any places around here that have sinkholes?
no. But from what we know about caves, where would we be able to find the nearest sinkhole when one forms?
above it.
Above a cave. So where's the nearest cave? Yeah, probably Wind Cave. Somewhere in the Black Hills, right? Because there's a layer of limestone. There's a layer of limestone under us here, but it's miles down. In the Black Hills, there's something called the Pahasapa limestone, which is in some places right at the surface, right? That's the area. If you look at the Black Hills from the sky, it kind of looks like a bullseye. And they have different layers of rock. We're looking at, this is map view, right? Map view. And this layer, we could say this whole layer here is limestone. And if you look at a map, well, sorry, atom thing. But if you look at a map of the Black Hills, and you like put an X over all the little like touristy caves where they say, come see Jewel Cave or Rushmore Cave or whatever, Mineral Cave, I don't know what they're all called. They're all in this layer where the bedrock is limestone, right? Because that's where caves form.
We should go to one cave as like a
We should. Okay, anyway,
Hey, we are.
we might. So this is how a sinkhole forms. If this happens over a large landscape over a long amount of time, we end up with this. Have you ever played Mario? You guys know about Mario?
Yes.
Yes.
So in some levels of Mario, there's like these spikies everywhere. You know about when there's spikies everywhere, and if you touch the spikies and you die? Okay, so that's based off of, well, I would guess, doesn't happen in real life anywhere except this, but when all these sinkholes kind of meet together in a place where the limestone has been exposed to the surface for a really long time, we get this thing called karst, write this down please, karst topography. I don't know where the word karst comes from. Of course, you know, topography is like the study of how the land looks. But karst topography is where all these sinkholes kind of meet up, and it forms this landscape where it's all really, really jaggedy. If you're watching the YouTube video, which I don't know if anyone is, but if you're watching the YouTube video, you can look up something called, I'm going to spell this wrong, but try to spell it like this, Tsingy de Bamaraha, I think. And we're going to look at that in a second after I finish this video, but there's this area in Madagascar, try to spell it right, I don't know if I did, but it's an area where this karst topography has existed for so long that the rocks are just like swords coming out of the ground. People hike it all the time, but you have to like wear
They
gloves
have
and
it
stuff.
off of, oh my goodness. Help me, somebody, what is it called? Yes!
Yeah, the movie's Madagascar.
Yes.
Yeah, so it's called. Yeah, the place it's located in Madagascar, like the island of Madagascar. Anyway, we're gonna look at pictures, but when people hike it, they have to wear like full body suits of basically armor. So it's like Kevlar, because otherwise, well, you know, if you fall, you'll still die. But that way, when you're like just touching the rocks, they don't slice you open, because all these stalagmites that were there when the place was underground as a cave, they're just exposed to the surface, just like in Mario. So if you fall down, right.
Are you just like, you know?
The end.
No, because they